Simplifying, multiplying, and dividing rational expressions is where we're starting today. Okay? So look at this giant example that's right here. 2/5 equals 40 100ths. Does 40 100ths also equal 2/5? Yeah? So you can make equivalent fractions by blanking both parts by blank. Any ideas? If we're going from here to here, you can make equivalent fractions by both parts by the same thing. You can simplify fractions. So I guess that was really like going from here to here. You okay with that? You can simplify fractions by going from here to here. How do we go from here to here? Both parts by the same thing. Same kind of rules still apply when you have rational expressions as opposed to just fractions. You can make equivalent rational expressions by, if I'm going from here to here, what am I doing? Good. Both parts by the same thing. You can simplify, oops, wrong color. Rational expressions by simplifying common. Very good. Okay. So we're going to start off really kind of slow and easy. What do you got? Can I simplify the numerator here? No. Can I simplify the denominator? Yeah, because they're both divisible by what? 4. If I divide a 4 out of each term, what are you left with? X minus 3. So can I simplify this fraction? Is there something in the numerator and the denominator that has a common factor? What is it? The 8 and the 4 are both divisible by 4. So if I divide both of them by 4, I'm left with a 2 in the numerator and a 1 in the denominator, right? So what's left when I simplify that? Perfect. 2 over x minus 3. What about a problem like number, let's see, how about number 4? What about a problem like number 4? Can I just cross out the 12s? That would be nice. Why? Why can't I do that? Those aren't factors, are they? They're part of another number. Did I show you the ridiculous thing on the board on Friday? Yes? Should I show you again just so you remember? Or was anybody not here on Friday? Yes? Okay. So you're saying, well, some people think, not you, not you, definitely not you. Some people think you can cancel out the 12s, right? If you can cancel out the 12s, you can also simplify 17 over 19 by crossing out the 1s. And by crossing out this part of the 7 and this part of the 9, because those are also the same. So that your answer is, that's ridiculous, isn't it? Fraction-wise, like us knowing, that's ridiculous. But to me, it's the same thing that you're trying to do if you're trying to cross out the 12s. It's ridiculous. because you can only simplify factors. Like we did up here, the 8 and the 4, those are both divisible by 2, or by 4, excuse me. And I get a 2 over 1, right? We can only simplify common factors. So I need to factor the numerator and then factor the denominator and see if there's something I can simplify. Okay? Look at the numerator. What are they both divisible by? 4. If I divide out of 4, what's left? 2x plus 3. Okay, is there something I can simplify out of the denominator? 4 also? Okay. What's left if I divide by 4? X minus 3. Okay, so what factors do the numerator and the denominator share? A 4. Those simplify to 1, right? Can I cross out the 3's? Right. No, because that's ridiculous, right? So what's our answer then? Over x minus 3, right? Very good. What about number 7? 7 looks hard. Oh, it's not? Okay. How do I factor the numerator? What do I get? 4 times x plus 2. Okay. How do I simplify the denominator? Oh, I got to factor it. Okay. Oh, so it's got a and c, so I need to do AC. AC is negative 12. B is 4. So it multiplies to be negative 12 and adds to be 4. 6 and negative 2. So 3x squared plus 6x minus 2x minus 4. Right? Now factor by grouping. What's common in these two? 3x. What's left if I factor out a 3x? Perfect. X plus 2. Now look at the second 2. What do I want to factor out? A negative 2, because I need in my parentheses x plus 2, and that's the only way to get it, right? So what's common in these two terms? X plus 2. And what's left over? X minus 2. So x plus 2, 3x minus 2. Can I try to trick you? Okay. What's common in the numerator and denominator? X plus 2. So do I cancel out the x's and then cancel out the 2's? What am I canceling out? What am I simplifying? The whole thing. X plus 2 over x plus 2. Good job not being tricked. So what's my actual answer? 3x minus 2. Whoa, I forgot my minus sign. Any questions about that? So what happens if some actual multiplication or division is happening? What happens if that's going on? Well, let's start here. 3/4 times 5/7. How do you multiply fractions? Okay, some of you are either saying or showing me the motions to cross multiply. What is it asking me to do? It's asking me to multiply, right? When is the only time I can ever cross multiply? When two fractions are equal. That's the only time I can cross multiply, when I have two fractions that are set equal to each other. Are these fractions set equal to each other, or am I asked to multiply them? Multiply them. So how do I multiply them? Yeah, just straight across. I multiply straight across the numerator and straight across the denominator. What is 3 times 5? 15. And what is 4 times 7? 28. So what steps did I just take? Multiply across. Do you see the difference between multiplying across and cross multiplying? Good. How is that going to be different when I have rational expressions instead? It's not. Are we doing this the easy way or hard way today? Easy? Okay. So what's 2 times x? 2x. What is x minus 4 times x plus 1? X minus 4 times x plus 1. What would be the hard way? Like multiplying it all out, right? Getting like x squared some nonsense like that. Is there a time for that? Absolutely. Now is not that time. Okay? We've practiced that enough. I know you know what to do. All right? What about number 2? Ooh, that looks hard. Oh, it doesn't? Oh, yeah, it's just 2 over 1. Oh, now I have 2 fractions. What do? I'll multiply across. There and there. So, 8 over 9. What steps did I take? Multiply across. So is this any harder? 3 over 1. Multiply across. Multiply across. Done. What do you think people try to do right here? Simplify it. Can you do that? No, that's ridiculous. Right? It's trying to do like the 17 and the 19, right? Okay. Ooh, this one must be much harder. No, it's really not, is it? Over 1. Straight across, straight across. 8 times x plus 1 over x plus 6. Done. So it must be number 3 that's harder, right? Okay. So what's different this time than like number 1 or 2? Well, we can simplify first. What can we simplify first? Wait, do we have to simplify first? No, we do not. We can multiply straight across just like we've been doing before. But if we simplify first, doesn't it make it easier? I mean, it's already so difficult to begin with, right? Okay, but what do you want to simplify here? Is there the same factor in the numerator and in the denominator? What? A 4. Is it okay that one's in one fraction and one's in the other? Yes. So this is a 1 and this is a 1. So now multiply straight across. What do you get? Would I have gotten that answer the other way? 4 over 36? Oh, they're both divisible by 4. Simplify. 1 over 9. Okay, so what steps did I take? Simplify and multiply across. Okay, so far? What do? Good. Now what? 2x over x minus 1. Now, why am I making sure I put a 1 here and a 1 here? I mean, is it really that important? Okay, we'll see. What about here? What about number 4? What do you want to do? Oh, 5 and 15? You want to do that right away? What's that? 1 and 3. Okay, is that it? 4 and 6 are not both divisible by 4. Oh, it doesn't have to be one of the numbers? Oh, okay. So a 2 and a 3. So what do I end up with? 2 over 9. Because after I simplify, then I... Simplify and multiply across. Okay, now here's where it gets hard, right? Still not? Okay, so x minus 3, can I do anything with that? X plus 5, can I do anything with that? X squared plus 9x plus 20, can I do anything with that? Oh yeah, I want to factor that, don't I? Okay, what multiplies to be 20 and adds to be 9? 4 and 5, x plus 4, x plus 5. All right, can I do anything with this? Oh, I can? What can I do? Oh, 2 times x minus 3, right? Okay. Now what? Okay, so x plus 5, simplify. Oh, and x minus 3's, right? So here is why I always write the 1. Do I have to write the 1? Really? No, it's enough for us to know that it's something divided by itself. I know that's 1. But if I didn't write the 1, what do people think is left in the top? Nothing, right? Is there still a numerator in this problem? Yes, and what is it? A 1. What's left in the denominator? 2 times x plus 4, right? Now, is it wrong for me to write x plus 4 in parentheses and then write a 2 after that? No, it's just not typically the way we write it, is it? Typically, if there's a number by itself, we write it out in the front, so we don't forget it. Okay? All right, for just a minute, turn your paper over to the back. You guys all have your calculators out, yes? Of course you do, because you get them out every day when you come into here, right? I would like you to do, in your calculator, 15 times 1/3. I don't care if you think you know what it is. I want you to actually press the buttons, please. 15 times 1/3 equals 5. Okay, now press these buttons. Actually press the buttons. 15 divided by 3. It's also 5. That's weird. Oh, it's not weird? Dividing by a number is the same thing as multiplying by its reciprocal every time? Does that work every single time? Multiplying by a number is the same thing as dividing by its reciprocal? Dividing by a number is the same thing as multiplying by its reciprocal? So if I ask you to do a problem like this, 23 divided by 1/8, would you rather do multiplication or would you rather do division? Multiplication, that's how most people are, right? So if I could make this a multiplication problem, wouldn't we like that better? Well, you just told me that dividing by a number is the same thing as multiplying by its reciprocal. So why don't we do that? What do we get? 16 over 3. What steps did we take? Multiply by the reciprocal. Do the same rules apply for rational functions? So this problem is really 2 times x plus 2 over x plus 3 times x minus 2 over 5? Is that what you're telling me? Multiplying by something is the same thing as dividing by its reciprocal? Or dividing by something is the same as multiplying by its reciprocal? Yes. What can I simplify? What do people want to simplify? Usually x plus 2 and x minus 2. First of all, they're not exactly the same. So if they're not exactly the same, we can't do it. Second of all, yeah, they're both in the numerator. Okay? So even if this was a plus 2 right here, and they're exactly the same, could I simplify them? No, because they're both in the numerator. I have to simplify things that equal 1. X plus 2 over x plus 2 is 1. X plus 2 times x plus 2 is not 1, is it? So what's the answer? There was nothing to simplify, so everything that's there is just part of our answer, isn't it? You okay? So look at number 6. What can I do? Do I want to divide? No. Multiply by its reciprocal instead. So 3/2 times what? 8 over 1. And then just multiply? Well, we can simplify first, right? What do you want to simplify? The 2 and the 8? So what's left? You know what somebody said last period? 12 over 1. Oh, that's the same. Oh, okay. So it was fine. Did I make fun of them at all? No, absolutely not. Okay? Because they were multiplying straight across, right? 12 over 1. If you want to write 12 over 1, you go right ahead. It's a little bit of waste of graphite, or in my case, ink, right? But is it wrong? No. It's not even worth making fun over. I'd rather make fun of how you say words sometimes, because you guys are weirdos when it comes to that sometimes. Parabola, that's the one I hate the most. Yeah. People say that. It's all right. I still accept them. Okay. What were the rules that I used here? Can I show you a little tiny shortcut here? If I'm multiplying by this reciprocal, can I just do this instead of rewriting the whole problem? Go ahead and move x minus 7 down here. What should I move up here? Can I do 2 steps at one time? You okay with that? Because see, now that's gone and that's gone because I flipped it, right? Or multiplied by its reciprocal. And now what? X plus 3 simplify to 1, right? So what am I left with is for my answer? Good. Over x minus 7, right? Good job. When can you simplify a fraction? When there's common factors. Only common factors. And where do they have to be? Numerator and denominator, right? 1 in the numerator, 1 in the denominator. Now all of the problems I gave you to do tonight are really more of simplifying fractions that are already there, not actually doing multiplication or division, but I did these with you, so I didn't feel like I needed to give you more examples of that. Is that okay? Would you please circle the following numbers? This one first. 2, 5, 8, and 3. And on the page that's stapled, 1 and 4 and 6 and 7 and 9. That should be 9 problems, yes? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. You got them all? Any questions?